What does changes in matter means? Now, when we have a matter in our environment or in our place of work or we do a lab, we know that there's a chemical reaction. So we know there's a chemical reaction because we've seen earlier, let's see if I can show it to you. When there's a chemical reaction, a new color, a new color is being created, a new substance, a gas, or it could be a precipitate, which is a solid, or there could be a change in temperature. Now, if there's a changes in matter, that means that somehow some particles got together to create something new. But what is important to say here is that there's a law of conservation of mass. So let's see if I can write it for you here. I think that is important. So I'm going to put this here. Let's do some editing live. It's always a good thing. So you get to see that we are doing things as we go along. So I'm going to take this one here. I like it. And I'm going to put it down here. So when we talk about changes in matter, we need to consider the law of conservation of mass. Perfect. I think I'm going to even put it, I think that's fair. We're going to put it this way. Let's see if we can do the slideshow right now. Perfect. When there is a change in matter, changes happen, we have to keep in mind that the law of conservation of mass needs to happen. So let's see if I can give you some example. So for example, I'm going to show you a quick experiment. So I have here a glass of water and an Alka-Seltzer. So here we know that we have water. It's a given volume, a given mass, and I also have here an Alka-Seltzer. Just to show you, I just took it from this package. So the Alka-Seltzer in the water, there's a mass for this tablet, there's a mass of water. When I put the tablet in the water, and you know what, I don't even know if it is too big. I'm going to just take a piece. I don't want it to overflow on my working table. So here's a little bit. I put it in water. Let's see what we see. We can see that there's a reaction happening. There's a new substance being created, and it is a gas. Now, what is interesting is that when we consider the law of conservation of mass, that means that the mass of that tablet or that piece of tablet is now mixed with water. But we need to consider that there's a gas going into the atmosphere. So when there's a chemical reaction, we have to consider that we have the mass of the tablet at the beginning and the mass of water. And at the end, we have a dissolved matter in water plus the mass of carbon dioxide that was liberated and created. This is important because you cannot create matter. Matter cannot disappear, cannot appear out of nowhere. We need to account for it. So here, I'm going to go back to my example here. So when we have the law of conservation of mass, that means that the mass of reactants, whatever we had at the beginning, needs to equal the mass of all the products of the reaction. So I have two examples for you here. So if I have rust, so I used to be a geologist. Here is my hammer. Let's see if I can show it to you. Let's see, where is my cursor? Perfect. So you could see here that my hammer is rusty. And the reason for that, it's been used in the field, and the iron in contact with the oxygen what created a new substance. So that means that my hammer is now heavier than when I bought it. It's not heavier by much, but all the oxygen particle that was mixed with the iron added mass to my hammer. So if you look here to this one here, so I have iron that was part of my hammer that got involved with oxygen. So we have 4 particles of iron that was mixed or was attached or reacted with 3 particles of oxygen, and this created a new substance. And the new substance includes the iron from the beginning and also includes the oxygen from the beginning. If you notice here, we have a chemical reaction. We have iron, Fe, O for oxygen. And here we have a little symbol that means that this is reacting to create here a new substance. And here we have an iron oxide 3. Now, if you were to count in individual little atoms, you would realize that I have 4 particles of iron. And here I have 2 of this big molecule, but this big molecule each have 2 iron. So 2 times 2 gives me 4 iron. So the iron at the beginning equals the iron at the end. We have here 3 molecules here of oxygen. But if you look into the product, we have 2 molecules of iron oxide 3, and each of the molecules have 3 oxygen. So 3 times 2 gives me 6, and therefore the mass of all the reactants at the beginning equals the mass of the product at the end. Another example I have, let's see if we can see it. Let's see. I just hope that you'll be able to see it in the camera. So here I have a wire. I don't know. So we have an electrical wire. Let's see if we can see. It's a bit tricky. I don't think it's a good example. So here I had scraped some of the wire. So we have brand new copper, which is shiny. It's beautiful. Oh, it's getting close. I don't know if you can see it. There you go. So you can see this wire. This one, let's see. This one right here is quite shiny. Let's see. There we go. It's quite shiny. I took away the layer of oxidization, the brown layer, because after a while, what will happen is the copper will be coated with an copper oxide, which is the oxygen from the atmosphere that will link with the copper. And here, that means that this area will be slightly more heavy. The other example I wanted to show for you, this one here, let's see if I can show you, is this one. So here I took a fossil fuel, which is a molecule of octane. So if you have a gas engine, we know that there's an octane content in the gas to make it work. The octane molecule is 6 atoms of carbon and 18 atoms of hydrogen. So this is a molecule of octane. Now, we know that when we burn octane in a car, we need oxygen, and oxygen comes in packages of 2 O2 like this. Now, if you notice, I have 2 molecules of octane and 25 molecules of oxygen. So here, why do I have these big numbers in front of the molecule? Is that when you have combustion and these 2 reactants react together to produce a new substance, the new substances are the following. We have a product which is water and carbon dioxide. So here we have 18 molecules of water and 16 molecules of carbon dioxide. And why do we have these numbers here at the front and we call them coefficient? That means that if you have 16 molecule of carbon dioxide, you have 16 atom of carbon or 16 particle of carbon. And if you go into the reactant right at the beginning, you realize that we have 2 molecules of octane, and each of these molecules contain 8 atoms or 8 particles of carbon. And since we have 2 of those, 2 times 8 equals 16. So the number of carbon on the product side, on the reactant side, equals the number of carbon on the product side. So the mass remains the same. So here the law of conservation of mass. Same thing with the hydrogen. So we have 18 hydrogen per molecule of octane, and because we have 2 of those, it's a total of 36 atoms of hydrogen. If you look here, we have 18 molecules of water because each molecule of water has 2 hydrogen, and therefore 18 times 2 is 36, and therefore we have the same number of molecules, the same number of particles of hydrogen on both sides. That means that the mass is the same. That follows the law of conservation of mass. And here we have, how come we have 25 molecules of oxygen is because if you look, we have oxygen in the products in both water molecules and carbon dioxide molecules. And therefore, we need a large quantity of oxygen to make sure that this combustion happens. Now, if you have a car with a combustion engine, what is interesting is we do talk about pollution, and we do talk about the fact that a car produces tons and tons of carbon dioxide every year. And how come we have all this tons of gases being produced? Think about that. When we have an octane, which is a liquid gas we put in a car, so we know that that has a mass, but this reacts with oxygen. And if you see the quantity of oxygen needed to make the reaction happen, and therefore each of the molecule of carbon dioxide, it takes one carbon of the octane and then two oxygen here and create new molecules. And that's how we have the mass of the tons of carbon dioxide being produced every year by combustion engines. And it's all due to this idea of law of conservation of mass. So as we are studying chemistry, we're looking at the idea that chemical reactions happen all the time, but we cannot invent or make matter disappear. That means that whatever we have at the beginning needs to be included in whatever we have at the end. If you have any questions or clarification questions, put them in the comments below. I'm here to answer your questions because the more we know about science, the more we can have amazing questions to make the world a better place. On this, take care. Bye-bye.